We are getting closer to our goal, folks. Next up is thorough testing, and once again there are interesting insights for electronics fans. My dad would be thrilled. He loved these cars already back in the day. Our goal is to develop replacement instruments for classic cars from the 1950s and 60s. Of course, preserving the original appearance is key. You can operate practically any analog sensor with any scale using that method. The concept and circuit diagram are set. Check out the earlier videos for more details. Today we are testing the temperature, fuel and oil pressure gauge. The voltmeter and ammeter will be covered in later videos. The first software version already has almost 30 parameters to adjust the new pointer drive. Any scale width between 0 and 350 degrees, left turning or right turning is configurable. Pointer speed, acceleration, clipping outside the scale and pointer damping are adjustable. For your orientation, we will be testing the path indicated by the jumper in the circuit diagram. Simplified, we have got a voltage divider made up from the sensor together with an internal resistor. We are measuring the voltage at the sensor using an analog to digital converter. The rest is digital magic in the code, which we are developing as well. For the following tests, a potentiometer is simulating the sensors. Using an ohm meter, we are plotting known points of the sensor characteristic on this scale. On the outer circle, we have the temperature in degrees Fahrenheit, which is high at low resistance and low at high resistance. On the inner circle I plotted the resistance. The red line is 0. The fuel sensor's resistance is increasing according to the fill level. 100 ohms is corresponding to full tank, 0 ohms is an empty tank. The oil pressure sensor works similar and varies between 0 and 90 ohms. A breadboard setup is good enough to prove that the principle is working. However, for more advanced tests, a stable setup is desirable. So I decided to solder the parts onto a universal PCB, helping also to estimate the space needed for the parts. When it comes to PCBs, you know what I'm about to say. Just check out PCBWay's website. The sponsor of this video is offering excellent services on this. It's so quick. Uploading Gerber files and ordering takes a few minutes, and a few days later you're holding high-quality PCBs in your hands. For me, they always work perfectly. Take the easy way with PCBWay. Back to our test, starting with the oil pressure mode of the new pointer drive. When switching on the ignition, this is the start procedure of the gauge, being the same for all modes. While the pointer's deflection range is matching the scale width, the 0 point is fitting not quite exactly. But that's no problem, we will perfectly adjust 0 through a parameter in the code. We are testing 90 ohms. And then we go to 0 ohms. Then to 45 ohms. And then back to 0 ohms. That looks pretty good, doesn't it? In case you're asking yourself the important question whether the electronics is suitable for ambient temperatures in a car, The processor's datasheet specifies minus 55 to 125 degrees Celsius or minus 67 to 257 degrees Fahrenheit. And the stepper is rated between minus 40 and 105 degrees Celsius, being minus 40 to 221 degrees Fahrenheit. The high requirements are crucial in the automotive field because, depending on its power consumption, electronic is becoming hotter than the already high ambient temperature. A good reason to check out the complete power consumption of our electronics. Derived from this chart, the processor is drawing about 10 milliamperes. The other parts are estimated using Ohm's law and basic electric power formulas. We need to consider a maximum of 106 milliamperes for the case all parts being active. The power dissipation of the electronics at the 5-volt level is low. Otherwise, it would be questionable whether it could survive starting in a car parking in the sun. Less than half a watt is occurring at the series resistor and the voltage regulator, which are dimensioned accordingly. The average power consumption is somewhere between the red and yellow values, depending on the configuration and operating state. The actual measured values of our test setup are slightly lower than estimated, which is good. We are on the safe side with our dimensioning. Next, we're testing the fuel gauge mode. Our parameter adjustment mentioned lets the pointer run perfectly between the 0 point and the maximum deflection. We're going to 50 ohms, corresponding to 50% fuel level. And then to 100 ohms. Perfect. Now I'm quickly turning back to 0 ohms to demonstrate the sluggish pointer control preventing unwanted movements due to sloshing fuel. Now it's getting more exciting, at least for me. We are testing the temperature measurement mode using a complicated sensor characteristic and a nonlinear scale on our dial. And what can I say? The expected values are all displayed exactly. Next, I'm testing the clipping function, stopping the pointer as soon as certain values outside the scale are exceeded or undershot. So far, all features are working great. I'm really looking forward to the final implementation. I'm always happy like a child when things are really working exactly as designed. I think it's an engineering mindset that you probably know, otherwise you wouldn't have watched the video up to here. Everything is looking fine, but we still have some work ahead of us. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.